In the previous video, we looked at a simple approach for writing unit tests for DOM components in Angular. Specifically, we were focusing on testing the behavior of the inputs and outputs of those components. If this component has this input, what should happen? Or in the case of outputs, what needs to happen for this output to be triggered with some specific value? This is a good place to start, but as I mentioned, it isn't the whole picture. A DOM component does not exist in isolation. It needs to be integrated into the rest of the application to actually do anything. And the rest of the application is going to require different types of testing approaches. This video is going to focus on completing the testing story within the Angular application. This will mean testing how smart components interact with those DOM components, how they interact with services, and we will also look at testing the services themselves. So we're going to do all of this in the context of the declarative state management approach I've been talking about recently with RxJS and Signals. I'll link to the full explanation video in the description, but the quick recap version is this. All state in the application is derived from sources which sit at the very top of the data flow in our application. These sources are RxJS observables. If we need to load some data in the application or some user action is triggered, one of these sources will emit some data. We then subscribe to these sources and use those values to determine how they should change the current state as a result, which is stored in a signal. Then the rest of the application uses these signals to get access to the state. Now let's consider how this plays into our testing scenario. At the moment, we have a DOM component and we are testing its inputs and outputs. Now we need a smart component to serve as the parent for that component. The smart component will supply the component with its inputs and we will write tests for this. The smart component will also handle the outputs from the DOM component. For example, the DOM component might cause the delete output to emit. So the smart component would need to take the data from that and trigger the appropriate source in the state management service with that data. So we will also write tests for that. Then we have the service itself. When one of these sources emits, it often needs to change the state signal in some way. So we are also going to write a test for that. With this approach, the application functions so consistently the same in most scenarios. DOM components are given inputs by smart components, they trigger outputs. These outputs are handled by the smart component, which usually means triggering some source in the service, and the service handles updating the state as a result of the source emitting. This means a lot of the time the tests can basically be the same, just with some bits and pieces changed around. Okay, so let's take a look at what this actually looks like. Let's just continue on from the example we had in the previous video. We tested that our DOM component renders a list item for each of the elements in the array it receives as an input. And we also tested that when the delete button is clicked for a particular item, it will emit the ID of that checklist on the delete output. Now we need to add our tests for its parent smart component, in this case the home page. So what should that smart component supply as input for the DOM component, and how should it handle the delete output? For the input in this case, we want to check that it supplies the DOM component with whatever the current state for the checklist is from our service. Since we are testing our smart component, not the service, we will create a mock version of our real service. This mock will provide some fake values for the checklist data, and we will check that it is this data that is supplied to our DOM component. Our checklist state is a signal, and signals have their values accessed through a function call. So to simulate this, we use jest's mock function and have it return the value we want. In this case, just some dummy data. That means when we execute this test, our component is going to be accessing this fake version of the signal, not the actual signal from our real service. So in our test, we just check that this dummy data has been supplied to the DOM component, and then we know that the smart component is doing its job. For the output, we want to check that it calls next on our remove source in the service with whatever data was emitted on the delete event. Again, we will use our mock to do this. We don't care at this point what the service does. All we need to know is that the smart component is nexting the correct source with the correct data. So we set up this mock version of our remove source. Usually remove would be a subject, but I've replaced it with this fake implementation that also uses a jest spy. As well as providing the ability to return mock values, spies will also allow you to check during the test if a method has indeed been called at some point and what it was called with. In our test, we trigger our delete output with some dummy data, and then we check our spy to see that it was correctly called with that dummy data. The final piece of the puzzle here is the service. We know the DOM component does what it is supposed to do. we know that the smart component is correctly handling communication between the dumb component and the service. Now we just need to check that the service is doing its job. Again, this Signals RxJS state management approach makes things quite straightforward to test. In general, we will just test triggering one of the sources and then check that the resulting state change was correct. To test our remove source, we will add in some test data before each test. I haven't shown you the test for the add source, but this is already done and functional. So you can find that in the source code if you're interested. Now we want to test that when the remove source emits some ID, it removes the checklist that matches that ID from the checklist state. To do this, we can just grab the first checklist from the checklist state to test and trigger our remove source with its ID. Then we check the checklist state to ensure that it no longer contains that specific checklist. We also want to make sure it is only that checklist that is removed. So I've also added this second test to ensure that just one checklist is being removed. Otherwise, just removing every single checklist would also be a solution for this feature. And there we go. Now we can be reasonably sure our component is actually behaving the way we want it to in the actual application. Now, a quick little disclaimer at the end, because I don't want to give the impression that things will always be as straightforward as what I have outlined in this video. Most of your tests probably will be if you are following this approach, but you'll inevitably run into challenging testing scenarios. For example, in this same application, I have a modal component that is a wrapper for the dialog component from the Angular CDK. This allows me to use it declaratively, and I can just pass in whatever ng template I like, and it will be displayed by the dialog. Now, long story short, this caused some awkward issues with testing, and I had to create a funky mock for my modal component. Fortunately for me, ChatGPT came in clutch with the mock. My point is, once you are somewhat experienced at testing, most of your workflow will go pretty smoothly, but it will be punctuated by frustrating issues that will make you feel like you suck at testing. This is normal, and just keep in mind that it's these challenging scenarios that help you grow the most. If you like this video, please consider a like or subscribe before you go, and I hope to test with you again in the future.